Chapter 8, Section 4, Properties of Logarithms. In this lesson, we're going to learn to use the properties of logarithms. So first, let's do some investigation. Okay. Complete the table round to the nearest thousandth. Okay, let's go log of 1. We got 0. Okay. Log of 2. Point 301. Okay, so 0.301. Okay, log of 3. Uh, 0.477. Log of 4. 602. Okay, log of 5. 699. Okay, log of 6. 778. Okay, log of 7. 845. Log of 8. 903. Okay, log of 10 should be 1. Oop. Log of 10, 1. Okay, apparently I didn't do log of 9. Log of 9, 954. Okay, then log of 15. 1176, so 118. Log of 20. 1301. Okay, so let's look at the compare in each statement. The log of 3, which is 0.477, plus the log of 5, which is 0.699, would give us, what would it give us? 1.18. And what is the log of 3 times 5? Well, what's the log of 3 times 5? Well, it would be the log of 15, right? What's the log of 15? 1.18. The log of 1 is 0. And the log of 7 is 0.845. And what is the log of, what's 1 times 7? 7. 0.845. The log of 2 plus the log of 4 would be 0.301 plus 0.602, which would be 0.903. And what is the log of 8? 0.903. Log of 10 is 1, and the log of 2 is 0.301, which would be 1.301. The log of 10 times 2 would be the log of 20, which is 1.301. Complete the statement. So the log of m plus the log of n must be equal to the log of m times n. How could you rewrite the expression log of m over n using the expressions of log m and n? Well, if multiplying them is addition, division would probably just be the log of m minus the log of n. Okay, so let's go through our properties. So hopefully that kind of proves to you some properties of logarithms. All right, for any positive numbers, mn and b not being equal to 1, the log base b of mn is the same thing as log base b of m plus log base b of n. The log base b of m over n is the same thing as log base b of m minus log base b of m. Okay, so that was the product property and the quotient property. Now, here's the other one, the power property. Log base b of m to the x power is the same thing as x times log base b of m. Okay, write those down. Make sure you understand and can memorize the product property, the quotient property, and the power property. Okay, they can obviously going to work in both directions. So, state the property or properties used to rewrite each one. So it went from log base 2 of 8 minus log base 2 of 4 to log base 2 of 2. Well, that's just the quotient property. Okay. Log base b of x cubed y is the same thing as 3 log base b of x plus log base b of y. Well, the first step was we used the product property to separate them into two different logs to add, and then we used the power property to get the exponent in front. So, state the log property used to rewrite. Log base 5 of 2 plus log base 5 of 6 is log base 512. So that would be the product property because we multiplied them. All right. 3 log base b of 4 minus log base b of 2 is log base b of 8. Okay. So the first one we'd had to do is rewrite it as log base b of 4 cubed minus log base b of 2. Well, 4 cubed is 64. So it would have been log base b of 64 minus log base b of 2. Okay. So it would have been the quotient property. So it would have been the product property and the quotient property. Okay, actually should have been the power property. All right, on the next one. Simplify logarithms. Write each logarithm as an expression as a single logarithm. So I got log base 3 of 20 minus log base 3 of 4. Base is the same, so I can say log base 3 of 20 divided by 4, which could be rewritten as log base 3 of 5. So the next one, 3 log base 2 of x plus log base 2 of y would have been first log base 2 of x cubed plus log base 2 of y. Now we can use the products. So now we can say log base 2 of x cubed y. Hopefully that makes sense when you follow through it. Next one, write this one as a single logarithm. So let's break each one down. So the first one would be log 2 cubed plus log of 4 minus log of 16. So we could rewrite this as, what is 2 cubed? 248. So we can say this is the log of 8 times 4 over 16. So that'd be 32 over 16. So that'd just be the log of 2. So answer C. Can you write 3 log 2 9 equal to or minus log base 6 of 9 as a single logarithm? No, they do not have the same bases. Okay, next one. Sometimes you can write single logarithms as sum or differences, so basically you can expand them if you need to. So expand log base 5 of x over y. Well, that's just going to be log base 5 of x minus log base 5 of y. Okay, the next one, you're going to work inside out, so you're going to work backwards. So that one would be log of 3 plus log of r to the 4th. Now you'll use the power property. So you rewrite it as log 3 plus 4 log of r. Okay. Next example. Expand. Log base 2 of 7b. So that's just going to be log base 2 of 7 plus log base 2 of b. You're adding them since it's a product. All right. Expand. Log of y over 3 squared. So I'm going to rewrite it like this first. Log of y squared over 3 squared. So I can rewrite this as log of y squared minus log of 3 squared, which is what? 9. Okay. And then I can expand it as 2 log of y minus log of 9, or you could say 2 log 3. All right, expand. Log base 7 of a cubed, b to the 4th. Well, if you wanted to speed it up, you could say this is 3 log base 7 of a plus 4 log base 7 of b. Each exponent becomes its own part. Okay. Next example. Logarithms are used to model sound. The intensity of a sound is measured in the energy it's carried by the sound wave. The greater the intensity of the sound, the louder it seems. This apparent loudness L is described or measured in decibels. You can use the formula L, this loudness, equals 10 times the log of I over IO, where I is the intensity of the sound in watts per square meters, and IO is the lowest intensity sound that the average human ear can hear. All right. So it looks like we have the threshold of hearing at 0 decibels. Okay, here we go. So let's look at the first example they give us. A shipping company has started flying cargo planes out of the city airport. Residents in a nearby neighborhood have complained that the cargo planes are just too loud. Suppose the shipping company hires you to design a way to reduce the intensity of sound by half. By how many decimals would the loudness have to be decreased? All right, the reduced intensity is 1/2 the present intensity. So let I1 represent present, I2 represent reduced, L1 present loudness, L2 is the reduced loudness. So we know we need to reduce in half. So we know I2 is going to equal 1/2 of I. All right, we know L1 by the equation given us too early is nothing more than 10 log I1 over IO. Okay, L2, the reduced loudness, is just going to be 10 log I2 over IO. Well, L1 minus L2 is 10 log I1 over IO minus 10 log I2 over IO. Okay, so we can put in some numbers. So we put 10 log I1 over IO minus 10 log 0.5 I1 over IO. Okay, so now we're going to break things down a little bit. So 10 equals log of I1 over IO minus 10 log 0.5 times I1 over IO. So 10 log I1 over IO minus 10 times log 0.5 minus log of I1 over IO. So we can distribute everything. We're going to cancel log of I1 over IO minus 10 log I1 over IO. So what's left is negative 10 log 0.5. So when we put everything in our calculator to solve, it's about 3. Okay, so the decrease in loudness would be about 3 decibels. So study this as example and kind of see what they did. Okay, the biggest thing is understand the equations that they used. Okay, the next video we'll finish this out.